Today's video is about a FortiSOAR malware incident management use case. So we will walk through the entire case management, starting with the tier 1, so triage. An alert is fetched from FortiSIM. It's an indication of an exfiltration. We have the main attributes, so source, destination, IP address, the amount of data exfiltrated, etc. And then we have a number of indicators that were automatically extracted and rated by cyber threat intelligence that we have interoperate FortiSOAR with. Now, to help us with this investigation, we have a workspace here where a bunch of playbooks generate a guiding messages, so it would assist the analyst into every step of the investigation. The investigation is also assisted with automation workflows, namely a number of playbooks that will be executed by the analyst to walk through the different phases of the investigation. As an automation tool, FortiSOAR is able to fully automate every single playbook of these ones, but they are obviously set to be manual to better show how FortiSOAR operates. Right. The first thing to do is to change the state of the alert. So we go from open to investigating. This will automatically compute the SLA, so the acknowledgement SLA. So you can see here the ticket stayed just 3 minutes in the queue. And then we have the next step is to get the details about the suspected infected device, namely this one. All right, so we start the playbook. The playbook will enrich the source IP address, and then it will create an asset record, which will have all the details that the playbook could fetch from a CMDB system. So we can see here, for example, the MAC address. We see the host name, the group, the property of the device that was potentially infected, etc. Let's go back to our alert. So this is just a simple enrichment state, and then the next stage is to get, or at least try to get, the logged on user at the time of the event. So we have another playbook which will probe FortiSIM in this case, and then try to find an event with a user associated with the source IP address that we see here. Now, if there isn't, we can see here the playbook logs. If the playbook fails to find the appropriate username, it will probe as you can see here. So it will, if the username is not found, it will probe the analyst to do this task manually. So basically, using the infrastructure to find the actual username logged on that particular system. So in this case, it's a manual task. So we go to the manual input, and then we set the username right here. Any username will do for the demo purposes. We go back to our alert, and here we'll see that the user has been populated naturally, and an indicator with the user has been created as well. Right. So we have the enrichment of the source IP address. We have the user connected on that particular system. To start with, we have the destination IP address, so where the data was exfiltrated, has been rated by cyber threat intelligence. So here, FortiGuard and VirusTotal, and the reputation is malicious. So that's the first indication in the triage process, and then we move forward with the investigation. So basically here we need to hunt the exfiltration process. We need to know what process was responsible for to generate this specific session exfiltrating data, and to do that we'll use this playbook. So it will use yet another time FortiSIM in this case. So it will search in the events what's the process responsible for this connection, and it has been found, so it's right here. And at the same time, we create the process as an indicator in the indicators section of the alert. The next step, so we have, just to summarize, we have the source IP, we have the user, we have the process involved in this alert. Now we need to get more data about this specific process. So there are a lot of endpoint solutions which have the ability to fetch specific binaries from endpoints. So that's exactly what we will be using. So we have a playbook right here, which will use the integration with the endpoint solution to fetch that specific suspicious binary. So FortiSOAR has the ability to parse even binary files, well, and non-binary ones, of course, and extract indicators from them. And this is exactly what happens. So we have this file has been parsed, and then it turns out that this binary file, hosts or has a hard-coded IP addresses in it, and you can see here the reputation is all malicious, which is a rather clear indication that this is an actual malicious file, and these IPs are very likely a C2 servers. Right, so let's dig a bit more into this binary that we have fetched from the endpoint via the endpoint security solution. We have here the reputation is not known. Well, simply put, because this is a 0-day. Based on the indicators extracted from the file, that's obviously a malicious binary. So we set its reputation manually to malicious. Finally, the work of the tier 1 analyst is done. So we are pretty sure this is a threat. So typically we escalate this to tier 2 to start the proper incident response for this particular case. So, and we do this by running the escalate alert to incident playbook. So we go back to the alert and we run the escalation process. So just another reminder, because it's very important to know it. Every single step that has been done so far could have been automated completely. So we are just doing it one by one to explain, to see the different phases of the incident management as we go. Right, so this ticket has been closed now. So the tier 1 is closed, and so the work of the tier 1 analyst is done. And at this moment, the tier 2 analyst will carry on. We can see the record for the tier 2. We call it incident. So after an escalation, an alert becomes naturally an incident. And this is the turf of the tier 2 team. And here we have the same, basically the same attributes as in tier 1, but slightly in a different presentations. For example, this graphical correlation, just in a glance, they would know what is this alert about and what are the different components. Similarly, we have in the workspace, in the comment section here, we have the guiding instructions. So first of all, we need to set the status of the ticket in progress. So we are starting working on it. And then we set the phase to confirmation. So before obviously taking any actions, we want to make sure that this is an actual threat and not provoking inadvertently a deny of service on our environment. So this is right. So this is done, and then the next step is extremely important because we need to know what's the extent of the threat. And to know that, nothing is better than checking whether using the SIM solution to see whether this file exists in anywhere in the environment. So to do that, we open the file, and then we have a playbook which will help us to perform that query or that search query on the SIM solution. So we run the hunt. We have the findings of the playbook right here. So we can see here that we have 5 matches, so 5 events that were matching the hash code of the malicious binary, and we have also obviously these events are coming from 5 different assets. So if you go back to our incident and we browse to assets, we should be able to see them all listed there, and also of course in the graphical correlation. Let's go to correlations, assets. There we go. So we have the original one, and then 5 more that were detected through the search in the SIM solution. Right. We also have the events, the actual events that were fetched from the SIM solution, and they are all linked to the indicator, which is basically the keyword or the search keyword we used for to get all these events. Right. So the events are right here. And as you can see here, the events are sorted chronologically. So if we check, as indicated here, if we check the first one, we should have some clues on what happened in the very beginning of the attack. So very interestingly here, we have we see that the binary, the file responsible for the exfiltration, was dropped by a Word document. So we have this Word document. Now what we can do is to push the investigation further. We can copy this file and then run yet another search on the SIM to see what events have this file name in it. To do that, we have a playbook called so create indicators and get their related events. So we can create one or we can use one or more keywords, and each keyword will be saved as an indicator. So whether it's a file name or an IP address or an FQDN or what have you, and each individual indicator will be responsible for a query, a search query, and then each match for that specific query will be stored as an event on that specific indicator. So let's run. Here we have just one. So let's run the playbook and then check what we have. Right, so we have this new indicator created, but to have a better look, we should better go to the incident view, where we have all our indicators right here. So we have one more indicator created. This is the one matching the file name that we found earlier. Let's open it. And we can see here that we have also 2 events. So one of them is naturally the one we found earlier, where we have the first appearance of the binary or the malware file, and then we have another one, a new one here. And in this record or in this event, we can clearly see what's the origin, where it came from. We can see the origin. I mean, which device downloaded it first. It's the same device, naturally, that where the binary was executed initially. And what we do, we can take this URL and then create it as one more indicator in the incident. So we go to add. We set the type to URL, which is what it is, and by this we would have completed basically the whole investigation. So we know if we trace it backward, if the list is pretty much enough of the indicators. So we can see that the malware was there's a doc file downloaded from this URL, and then that doc file was used to drop a malware file. That malware had a number of C2 servers hard-coded in it, and it was used to exfiltrate, to use one of them to exfiltrate data outside. And at the same time, several other devices were infected by a lateral movement. So if we go to our correlation, we have here in the assets all the other infected devices. So by now we are pretty much sure what happened, and then we are ready for the automated incident response. So we have a playbook here called Malware Incident Remediation, which will perform a series of tasks to contain the threat. The first one is to identify the first infected user, and then quarantine the infected devices on the next generation firewall. The same thing for all the C2 servers that were extracted from the various artifacts. and also the URL from where the first file was, or the dropper file was downloaded. And finally, we disable the user from Active Directory to prevent any other lateral movement. By now, we have a couple of pending tasks. The first one being the assessment of all the other infected accounts, which have eventually to be disabled on Active Directory as well. And finally, to recover all the infected machines and put them back in production. And by this, we get to the end of this use case today. So I hope it was useful, and see you in the next one.